Welcome back to the Code Wolf. Today we're going to explore how to use Semantic Kernel to build AI-powered apps and agents. Semantic Kernel is simply an SDK for building AI-powered apps, agents, or tools, and it's available for C#, Python, and Java. In this video, we'll work through essential concepts step by step to code an AI agent that can retrieve and archive current news stories, a task most AI models are terrible at because their training data is from the past and they can't automatically retrieve new data. We'll also learn why you'd want to use Semantic Kernel in the first place over other SDKs. Let's get started. Please remember to subscribe and hit the like button to support the channel. There's always more AI, cloud, and coding videos on the way. These videos are a good amount of work to create, so the subscriptions really help. So to start with, as a comparison, I have the standard Azure AI chat playground open, and you don't have to use Azure for this tutorial. We'll see how you can use other open AI options as well, but I just want to use this UI to demonstrate a concept here. So if I were to say hello, and the AI will of course greet us, and I'll say, get me current news from today. And right away, this is going to tell us I'm unable to browse the internet in real time to provide updates. And if you ask it some similar prompts, it'll tell you that its training data is actually from 2023. And so obviously it can't just generate news without going out and referencing some other sites. So we're going to improve this by building a custom app that talks to this exact same AI model, but gives it the ability to go out and get news. And I actually have that app running. So this is the completed app in Visual Studio. And I'm just going to say hello. And this is the same model. And it's going to say, hello, how can I assist you? But you can see it also asks for news, since this is now a news-oriented agent or more custom tool. And I'll just say, yes, I'm looking for news. And then it's going to ask us what category we want. And so I'm going to say technology. And now it's going to go out and get current news for us. So this is news from today. This is all up to date. And when it finishes, it's going to ask if we want to save these articles and to provide a file name and such. So I'll say, yes, save all of the news in a file called tech. And so now the agent is going to crank through that, and it's going to add a file to our project called tech. And so if we open it up, there's the same news stories that it wrote out in the console. And this workflow is actually dynamic. Our app just sort of pieces together this workflow based on our prompts, as we'll see in a moment when we start to build this. So let's get into it and start working with Semantic Kernel. So at the most basic level, you can think of Semantic Kernel as a lightweight AI orchestration toolset, sort of similar to something like LangChain. However, I find Semantic Kernel to be more approachable than most AI orchestration tools, even though it's arguably also a little bit more limited in scope or capabilities. AI orchestration toolsets allow you to wire up many different models, services, plugins, data sources, and configurations to more easily manage the flow of data and prompts and completions in an app. They act as an abstraction layer above just using one simple SDK, such as the OpenAI SDK, to provide more extensive capabilities and integrations. If that all sounds confusing, no worries, it'll start to click as we build our app. To build that app, we need to sequentially cover 5 semantic kernel concepts one at a time, which are the kernel itself, services, plugins, planning, and personas. So let's start with the kernel. Almost everything you do in semantic kernel runs through the central kernel component. The kernel is used to register services that connect to AI models or to register plugins that contain custom functionality. It's where you set up essential configurations like logging or other features. Let's see how to set up an app with the Semantic Kernel SDK installed and create our initial kernel. All right, so I have Visual Studio open with a default console app for .NET or C#, and I haven't done anything to this app. It's just the default starting point. So the first thing we'll want to do is right-click on our dependencies and go to Manage NuGet Packages. So we want to add the Semantic Kernel SDK or package to our app so that we can work with it and all of its great features here. So I'll search for Semantic Kernel and then just choose this third one here or wherever it is on the list, just Microsoft.semantickernel, nothing after it. This is important. Make sure you get the right package there. And let's say install. and accept those license terms if you agree with them. And then let's go back to our program file. And we don't need any of this boilerplate. Let's just start with a blank file. So the first thing we need to do is say var builder, and we want to use the kernel.createBuilder, and that'll pull in our namespace for us up here. And if you've worked with other .NET apps or similar types of projects, you might be familiar with the builder objects. So Semantic Kernel has one as well. And this builder object will allow us to add services, and it'll allow us to register plugins. And then when we actually build that kernel, those will be available for us to use. So further down, we can say kernel equals builder.build. And so once we've worked with these other features up here, those will be available on our kernel. But now we have a kernel, and this in itself can do a variety of things. So if we use IntelliSense and browse here, we can see there's all kinds of features for working with plugins and data, and we can even invoke prompts directly if we set up some service configurations and such. So this kernel can do all kinds of things, but now we have one in our app and we're ready to start building additional features. Next, let's talk about services. Semantic Kernel allows you to register multiple services with the kernel to talk to different AI models or external services. For example, you could add multiple services to talk to OpenAI, Azure OpenAI models, local AI models, and so on, and it can understand which service to use for different tasks based on context. The main Semantic Kernel package provides built-in support for the OpenAI style models, and it's extensible enough to include support for other types of AI services as well through additional packages or plugins. Okay, so let's see how to add a service to our app that we can use to talk to an AI model. Now, to start with, I'm just going to paste in a line of code here to make sure we get this key and endpoint right. So this code wires up our kernel to talk to Azure OpenAI, and it'll give us a chat service to do that. So that's why we have to pass in our model name and the endpoint and the security key here. But if you're not using Azure OpenAI, there are other options here. So we could just say add OpenAI instead of Azure OpenAI. So there's a chat completion service for that as well. And this even supports local AI models through this method. So whatever AI service you use, just pick the right registration method here. So I'm going to switch back to Azure. And I do want to mention that this is the only line of code in the entire app that will have to change if you're using Azure OpenAI versus regular OpenAI, for example. So Semantic Kernel kind of abstracts away some of these details for us. And that's one of the really nice things about these higher level orchestration SDKs. So we're all set up to use Azure here. And now let's actually get a chat service to work with. So further down here, let's say var chat service equals kernel.getRequiredService. And let's ask for a chat completion service. And once we have this service, we can start having a conversation with our AI model. So first, let's create a history object here. So this will preserve all of our chat messages, if I can type this correctly. So this will kind of preserve a conversation back and forth with the AI to give more context, so it'll be able to reference past messages. So now let's kind of set up our basic while loop here to talk to our AI model. So first we'll want to get a prompt from the user to send off to the AI. And so we can add that to the conversation history. So we'll say add user message, and let's get the console.readline. So when we run the app, whatever they type in, that'll get added as a user message to the chat history. Then we want to send that prompt off to the AI model and get a completion back. So we'll say var completion equals chat service dot get streaming chat message contents async. What a method name. And we'll want to send in our whole conversation history. So there's our chat messages. And we also want to pass in our kernel that will contain some essential configurations. This will be more important later on, but we'll just do that right now. So from here, let's handle the message back from the AI. So first we'll create a string here to store that streaming response. So we'll say await for each var content in completion. So this is going to kind of loop through all the different content pieces in that completion response as they stream back. So first we can say console.write, and this will write out the content pieces to the console so we can see them. But then we also want to save those pieces in the full message so that further down we can add that to our history here. And for this, we actually want to say add assistant message. And so This line will kind of help store that conversation as we go along. Let's also end this with one more console.write line here, so that will give us a clean break in between each message series. So just to recap here, we register our Azure OpenAI service, then we get a chat service using that configuration, and then we use that to create this kind of standard chat loop back and forth with the AI. Let's run this and see what we have so far. So when the app starts, we have our prompt, and I'll just say hello, and right away we'll get a response back from our AI. And so if I say, how are you today? It's going to give a friendly response back, but our AI chat is working. So the services portion of Semantic Kernel is set up. We now have an Azure OpenAI chat service set up. Next, let's talk about plugins. Plugins allow you to connect existing web services or REST APIs or just custom code to the kernel to add custom functionality. For example, you can import a REST API spec for an existing service to make all of those endpoints available to the kernel. You could also just write custom code classes and functions right in your app and register them with the kernel so it can use them. The kernel is smart enough to automatically know when to call these REST endpoints or custom functions if you set things up right to complete tasks or workflows for the user, as we'll see later. All right, so now let's see how to add a plugin to our app to give our AI capabilities it wouldn't have otherwise. And that's going to be that news retrieval functionality. So let's actually add our plugin in a new class to kind of keep things organized here. So I'll call this news plugin. And the way this news plugin is going to work is it's going to go out and retrieve an RSS feed from a news site. So RSS feeds are kind of a standardized format of displaying simple news headlines with some additional data and metadata. So I have an example open here. So this is a news feed from the New York Times. You can use whatever news site you want. Most of them do have an RSS feed, so you can see that special URL at the top. We've got rss.newyorktimes. But anyways, these include various metadata and some headlines for us. So you can see there's a technology category here, and it's talking about Elon Musk. And there's some different metadata, including a link to the full article and such. So most of these RSS feeds contain similar nodes here, such as a description, and it's a pretty standardized format. So this will give us a good option for retrieving news. Now in C#, there's plenty of NuGet packages out there to help us retrieve news. So let's go to Manage NuGet Packages, and there's one called Simple Feed Reader that I think is extremely easy to use. So go ahead and install that. I've already added it to the project, but that's the one that you'll want. And so back in our class here, let's create our kernel plugin. So the first thing we'll want to do is add a method, and this is going to return feed items, which are a type from the Simple Feed Reader NuGet package. So I'll pull in that namespace, and this will be called getNews. And because this is a plugin, we'll want to pass in our plugin object, and we're also going to pass in a category, so the user can specify what type of news they want, such as technology or education or world news or whatever. And so inside this method, let's use our NuGet package functionality to get those news items. So we'll create a reader. So there's a class called feedReader. And then on the next line, we can just say return reader.retrieve_feed. And here we can just take the URL from our RSS feed and plug that in right here. So that just shows how easy this is. It'll just kind of directly go out to that URL for us. But we want to replace this technology category with our category parameter. So now we'll be able to pull in different types of stories based on whatever the user specifies. However, we don't want to return the entire RSS feed because some of these can be pretty long. So we'll also just say take 5. So I'll bring this down onto a new line. And then let's also just convert this to a list since that's what we specified as our return type. So now this will go out and get 5 RSS feed items. Now, to really turn this into a semantic kernel plugin, there's just a couple attributes we have to add here to help the kernel understand what this plugin is used for. So first we can say kernel function to just define this as a function, and we'll say get news. So this is kind of the main function of the plugin, and you'll want to use snake case apparently. I guess there's some Python syntax stuff behind the scenes, so it helps if this is in snake case. So just define it like that. And then we'll also need a description. So we can say gets news items for today's date or today's current date, just some keywords to help it understand what this plugin is actually for. And then we can also help it understand what this returns. So we can give it a return description and say a list of current news stories. So up here, we could probably just remove this current and just say today's date. And down here, we say current news stories. So we cover both scenarios. And I'll just fix the syntax there. But now we've got our complete plugin. And so the last thing we have to do is register that with our kernel. Remember, we kind of stubbed out this plugin area earlier. So we can say builder.plugins.add from type, and then pass in the news plugin type, and that'll pull in our namespace. So now that's available on the kernel, and it can reference it whenever it needs to. Now, there's just one last thing to get this working in the way that we want. So down here, we need to tell our app that it's okay for it to execute functions for us automatically. And so there's this extra parameter here called execution settings. So we can say OpenAI prompt execution settings, create a new instance of that. And then there's a property here called tool call behavior. And we'll set that equal to tool call behavior.auto invoke kernel function. So there's our auto functionality that'll let us execute our plugin. So now this is properly set up. We've got our plugin registered with the kernel, and let's test the app to see what we have so far. So I'll just zoom in here and say, get me today's news. And it gives us kind of an odd response, but it does say if you're looking for news on a specific topic or category, it'll try fetching it for us. So let's say technology and see what it comes up with. And there's our RSS feed. So if I kind of expand this, you can see that this actually matches what was out here on our RSS feed. So there's the same title. And so we know that's actually coming from the news site. And just to double verify, we can actually put a breakpoint in our plugin. And if we run this again and say, get me current news stories, you can see we do hit the breakpoint in our plugin, which is pretty cool. The AI just automatically invoked that because it understands the metadata on our plugin. And you can see it's asking for a category again. So I'll just say education, and it hits the breakpoint again. And it starts to bring back items from our RSS feed. So this is awesome. We now have a plugin that's adding new functionality to our AI. Now it's time to talk about planning, which is my favorite feature of Semantic Kernel. The planning feature enables your app to use the services and plugins registered with the kernel to dynamically accomplish tasks. Planning relies on a feature called function calling, which enables the AI to invoke plugins and services based on its objectives. You can even configure the agent to use automatic function calling, which means the kernel doesn't have to ask permission from the user to invoke that registered service or plugin. It will just automatically perform whatever actions are necessary. Okay, so now let's see how we can start to use planner functionality or planning functionality with our kernel and our app here. And I think this is the coolest feature of Semantic Kernel. So essentially, as we start to add services and plugins, Semantic Kernel keeps track of all those different resources, and it can kind of automatically understand which ones it needs to use to accomplish a specific task. And this is easier to demonstrate if we have more plugins or more services set up. So I've gone ahead and created this really simple archive plugin. We already saw how to create plugins in the last section, so this is pretty much identical. It's called the archive plugin. And all this does is write the news story that we retrieved to a file in our project. So I've just kind of hard-coded a path here as an example. But it also accepts a file name and a data parameter. And so Semantic Kernel is going to be able to figure out what these mean and what these are used for. But we help it out with some additional attributes again. So we say that this archives data as the main purpose of the function. And we say saves data to a file on your computer as the description. This does not return any data, so we don't have a return description, but same thing as our previous plugin. And so now back in our main program file, all we have to do is register that again. So we'll say add from type, and this time it'll be the archive plugin. So now we've got two plugins, and Semantic Kernel will understand what to do with these based on our prompts. So let's run the app again and test how this works using a sample prompt here. So if I were to say, get me current news, just like we did earlier, it's going to hit that breakpoint again. So I'll just get rid of that and continue here. And it's going to ask us for a category. So I'll say technology. And when I hit enter, it's going to print out that news for us again. However, there's now additional capabilities that this can do because we have our plugin. So if I were to say, please save that data in a file called hello world. Let's see what it comes up with. So it's thinking for a moment, and after a second, it says that data was successfully saved in a file called hello world. And if we open that up, there's our news headlines. Now, this is really awesome if you think about it. There's no code in our app that says after you've retrieved news and I tell you to save something, then use this plugin to save it and pass in the data. It just sort of automatically understands that functionality. So you'll notice it didn't ask us for the data parameter. It just understands that the data comes from the previous response and kind of the context of the conversation. And what's also really cool about this setup is that you can kind of combo things together based on your prompt. So if I were to run this again, let's see what happens if we say something like, get me today's technology news and save it to a file called tech. So here I'm putting both workflow steps in one prompt, and we'll see if the AI is able to figure out what it should do. So in the previous example, we used 2 steps. Now we're just bundling that into 1 step. And let's see what it came up with. So it created this tech.txt file, and sure enough, there's our news stories. So this is a good example of how the planning functionality can kind of just build out workflows dynamically based on the services and plugins and resources and configurations that are set up on your kernel. Finally, let's talk about personas. A persona is a sort of meta prompt or instruction that influences how the agent responds to a given task. You can sort of think of personas as glorified system prompts if you're familiar with that concept. For example, you can set up your agent personas to consistently ask for clarifications or extra info if it's unsure of what to do next. Okay, so last part of the demo here, let's give our agent a persona to give it a little bit more personality and to kind of help guide it through some user flows. And we can do this by just passing in kind of a default prompt into our history. So we can say something like, you are Mario the plumber, and that will kind of change the way that it speaks or the way that it presents. And then let's say something else like, if the user doesn't provide a news category, ask for one. And then we can also say, if the user retrieves news, ask if they want to save it and get the file name. So we're just kind of adding additional instructions to our agent based on different scenarios and kind of just guiding it through this process. So we'll see what it comes up with here if we were to run the app. And these are kind of specific instructions just to kind of give an example, but you can also give more general high-level workflow instructions. So let's just see how this works. So I'll say hello, and now you can see that it thinks it's Mario the plumber. And you can see right away it also asks about news and the category. So if I were to say, get me today's news, now it's going to more explicitly ask for the category. If you remember, our previous responses were a little awkward, or they kind of implied that there should be a category, but here we're actually asking for it specifically. So I'll just say sports, since that was one of the suggested ones, and you can even manipulate what those suggestions are by changing the description and metadata in your plugin and such. But now you can see it specifically asks if we want to save the news and asks us to provide a file name because we told it to in the prompt. So I can say, yes, please name the file sports, and press enter. And sure enough, a sports.txt pops into our project, and that has the news in it. Now here it used a slightly different format than before when it saved it. This kind of shows how AI can have a life of its own or a mind of its own, but you could further refine this through additional context and such. But the key takeaway here is that you can just manipulate the behavior of your AI and of your workflows by configuring the persona. And an easy way to do that is to just pass in a default system message into your chat history. And this at least gives a good example of how we can clarify or improve our workflows by providing more context to the persona. So at this point, we have our agent all set up, but there's still plenty more that you can do with Semantic Kernel. If there's interest in this video, I'll create a follow-up to explain additional concepts such as memory, filters, or integrating multiple AI services or APIs at once. Remember, there's tons of additional connectors and packages available to extend the functionality of Semantic Kernel. We've barely scratched the surface here, so I encourage you to keep exploring. Thanks so much for watching, and I'll see you next time right here on the Code Wolf.